Hi everybody, this is Stephen Pugh, City and Guilds Construction, City and Guilds Carpentry and Joinery course. This is video number 10 and we're going to be looking at roofs today. So what I want to do really is plunge straight in, and we're going to talk about the different types of roofs. Most people think only in terms of a pitched or a flat roof. There are quite a number of different types of roof, and it's quite possible that in an examination you might be asked to describe quite a lot of different types of roof. Everybody knows what a flat roof is. It's just a simple box with a flat roof on it. Of course, it's not completely flat. It has a bit of a fall to it of about 1 in 100, which causes the water to trickle to the one end and into a gutter. Sometimes the fall is greater than that, 1 to 60. And then, of course, we all know what a lean-to roof is. A lean-to is very simply like a shed would be up against the side of a house. That's a lean-to. In other words, the roof is leaning onto the side of the house. A gable-end roof is a roof where the walls are just going to draw the picture. There we are. There's a gable end roof. It has a gable at the two ends, and a hipped roof looks very similar. Well, no, I won't say it looks similar. It looks quite different. It has hips on that look like this. Okay, so the first one then is a gable end. You've got the gable at each end, and then you've got a hipped roof. And there is another type of roof which City and Guilds, in fact all joiners talk about. They talk about a mansard roof. A mansard roof is a special type of roof. I'm going to draw it for you. If you can imagine, when you're going to construct it, you have a simple line that goes across like that, and then you have a circle that comes across it like that. Okay, imagine a circle. And then if you can imagine, you break the circle in those three places. Okay, and then you draw a straight line between the two. So a straight line across the two like that. And what happens then is you have an interesting shape which you often see at the seaside. These types of roofs are used a lot near the seaside, because what they do, instead of having a normal pitch roof, they will have a roof that is constructed in such a way that it gives the house extraordinary protection from gales. Okay, so now that you see the overall shape of the house, you can see now that the house often will look like that. Okay, in fact, to give it some perspective, it would look like this. And very often in the side of the roof you will see dormer windows. I'll draw a small dormer window in it so that you can see what I mean. But there's a mansard roof. Now a mansard roof has tiles across the roof, as normal houses do, and all the way across. Now you can imagine when a storm comes how very much better this is at protecting a house from exceptionally bad weather. So it's an exceptionally strong construction, okay, and that's what a mansard roof is. So we're going to have to use this little diagram board now and again as we're talking. So there's a number of different types of roof. You've got a flat roof, and then you've got the pitch roofs, the lean-to, the gable end, and the hipped roof. Now, on a roof that has a hip or a roof that has gable ends, there are a lot of components to it, and I'm going to be showing you some pictures of these various roofs. If you have the textbook, you can open it right in front of you and look at everything. That's very much easier. But we need to talk about roof components. I'm going to clip this picture out of the book and show it to you on the thing. You can see there's the different parts of a roof, and on that picture you can see you've got the hip rafter, you've got jack rafters, you've got purlins, you've got a ridge board or a ridge beam. A ridge board is thin and a ridge beam is very substantial. You've got cripple jack rafters, you've got valley rafter, you've also got tiling battens, and you've got the wall plate. Now these are all words which carpenters all know about, and they're words that are the language of our trade. So it's important that you become familiar with what all these different words mean and what all the different components on a building are. The other thing to remember is that these roofs are not just sitting on the building, they're actually tied to it. What happens when there's a very bad storm is that a wind comes, and as it goes over the top of a roof, so it creates a suction, and it's possible for a very high wind to lift a building right off lift the roof right off a building and dump it a few streets down. Of course, this is highly dangerous, and in this country, by law, we have to put in wall straps, and we have to put in roofing straps. Now, what these straps do is they strap the roof structure down to the brickwork, and it's all fixed and nailed in such a way that it would take very, very, very extreme weather to be able to ever remove that from the building. Now, there are a number of other words which are important. We need to understand them. There's a word called barge board, and this is the board of timber that goes up the front of a gable end. Okay, it's a large wide timber that goes to the top and then comes down the other end. That's called the barge board. If you go to other countries, you'll find that almost invariably they make these boards to be very ornate indeed, and they're all heavily carved. It's one of the features of some cultures. You'll also notice that at the bottom of the barge board there is a little tilting strip, okay, sometimes called a fillet. There's various words. And what this does, this causes the bottom of the last few slates or tiles to just tip up a little bit. This slows down the transport of water down the roof, and as it slows it down, it then enables the water to pop straight into the guttering. Now, the guttering is attached, generally speaking, onto a fascia on the front of the roof, and underneath it is a thing called a soffit. And what a soffit does, it's generally made out of fireproof material, and what it does, it prevents fire from licking underneath an open boxed eaves and actually setting it on fire. So that's why it's nearly always fireproof. It is always fireproof. That's the regulations. So there we are. That's a bit of a description about some roofing. It's possible sometimes for a roof to be constructed in a factory and then brought and just put onto site and nailed together. And this is the process that we call trussed rafters. So these are rafters that are made in a factory, exactly the right shape. They're all nailed together very accurately and very firmly, and then they're brought to a site and they're literally lifted into place and then tacked and nailed, and that's called truss rafters. There's lots of words to do with roofing. For example, slate is actually stone. It's a special type of stone which is quarried in the mountains. There is cement fibre slate. So this is not slate at all, but this is actually cement tiles that look like as if they're slate. And then we have roof tiles. Now these are slates, if you can understand what I mean, but they're made out of clay. They're made out of the same material as bricks are made of, and therefore they're exceptionally strong. They're also quite heavy. There is flashing. Now flashing is the strip of lead work, generally speaking, that goes around chimneys or goes against a wall. If a roof is coming down and it's got a wall here, then there will be flashing coming down the side, and that of course is a whole subject in its own right. It's generally plumbers that are involved in putting flashing in place because it's lead work. So that's roofing. Now obviously there's an awful lot to the subject of roofing, but we're going to just push on a little bit. We're going to talk about services, and often services are very, very important to a house, and often there are more than just the three. I mean, for example, we have water being delivered to the house, fresh, clean drinking water. We also have a supply of electricity, and we also have a supply of gas. Now gas, it can be supplied in various ways. It can either be a direct link by pipe, or it can be bottled gas. But either way, we have at least these three services that come to a site. Sometimes you get things like telephone wires. Sometimes you get things like cable wires for cable TV, and there's other types of services that are a little bit unusual, but they can sometimes come into a building. So let's talk about water. Water's brought in using pipes, and these pipes are all buried well underground, usually something like about 600 millimeters below the ground, and the purpose of that is to keep them from frosting. So they're right underneath the ground where the ground is warm and they're protected, and they come up and they go into the building and go directly to your tap, so that when you turn your tap on, you get pure drinking water. Normally, these pipes that are in a building are made of copper, but increasingly they're being made of plastic. So a special type of plastic, not just any old thing, but a special type of plastic. They're exceptionally safe. They're very, very easy to work with, and you literally just cut the pipe, put it on, and it's done. There's no welding, there's no heat work with plastic pipes. Of course, the copper fittings, they need a certain amount of skill and expertise to be able to get a seal that's perfect for the pressure of water. Now, not only is water carried into a building, but water is carried away from a building. For example, if you have either a flat roof or a pitch roof, the water that comes from the sky, the free water, the rainwater, it comes down onto the building, goes down into the gutters, and then it goes down from the gutters into downpipes, which then go down into the ground, and they carry the water away from the building. They normally carry it away up to about 20 feet, and generally there's a thing called a soakaway. So underneath the ground there's a pile of rubble, and the pipe goes into it, and that rubble enables that water that's coming from the sky, the rain, enables it to be filtered away into the ground. Okay. There's another type of water that leaves a building, and that's sewage water. This, of course, is black water. This is the sort of water that comes either from the bath water, or from sink water, or from toilet water. All of these types of things, they all leave the building under different types of pipe work. Now that water, it goes all the way to the sewage works, and in the sewage works, that water is filtered so thoroughly and so completely that in the end the water is then drinkable again. Wow, that's a big thing, isn't it? Water's a big thing, and there's all these different aspects of water in relation to a building. Now, of course, there's also electricity. We don't major on electricity when we're carpenters and joiners, but certainly electricity is a very big thing. It powers all the lighting and the heating and all the appliances in a building, and it's brought into the building through cables, which is not really a subject that's of our concern. Gas is brought into a building using pipes, whether it's mains gas from the gas grid. If it's coming in on the gas grid, then there is somewhere in the country, sometimes there's 2 or 3 large jet engines which push this gas along the pipes. A certain amount of smell is put into the pipes, because you see gas that we receive for our cookers and so on, or for heating, has no smell to it. So they put a special smell into it, quite a strong smell, which means that if there's a leak, then we're able to smell that there's a leak. Otherwise we would not know there's a leak, and we would all die from gas poisoning. So that's gas. Also, there's another form of gas, and this is bottled gas. This comes in tanks, sometimes in little tanks that you just buy, small ones at a time, or sometimes it'll be a very big tank situated at the rear of a building, and this can be used for everything that's needed, either for heating or for cooking. And then, of course, there's all the other things. There's the cable, there's broadband, there's entertainment systems, there's telephone wires, there's all the other services that come into a building. Now, the next thing we need to think about in relation to all these subjects is the question of sustainability. And under sustainability, it's all about, are we cutting down all the forests and using all the wood and not bothering to replace? In other words, if you cut down all your forests and you use up all the wood, you get to a point in which there's none left. So sustainability is not about not cutting down the forests. Sustainability is all about putting back into the forests in new trees that will replace the ones that we're cutting down. Okay, so this is all about having a sustainable source. Okay, so you're using the wood, but you're also planting wood, and there's this constant cycle. And there's other considerations apart from just sustainability in terms of the source of wood. We need to talk about how far the materials have been brought. Is it locally supplied timber, or is it being brought from the other side of the world? That's a big issue. Are the materials sustainably sourced? Has the timber come from forests that are properly being replaced? Sometimes they're not, you see, it just depends. Has the material been manufactured with a minimal amount of energy necessary and waste necessary? So these are considerations as well. It's a very big deal. Also, the question of sustainability comes into the design of buildings. For example, some buildings nowadays can be made out of straw. They can be made out of cob. And now cob is a particular type of soil. It has a certain amount of clay aspect to it. Some buildings can be made out of cob. You can build obviously out of timber. It might be some of the redwoods, or it might be spruce, or it might be oak, depending on what your preference is and how much you can afford. So timber is used for building. Sometimes timber can be used, buildings can be built out of bamboo. Now, not so much in this country, because of course the distance you'd have to bring bamboo is quite great, but certainly that is one of the considerations. It's one of the materials that increasingly is being considered for the future. The other material is lime. Lime is a special product produced from limestone, in which it is manufactured in such a way that when you mix it with water and sand, it immediately turns back into a hard substance. It's not cement like Portland cement would be. It doesn't become rock solid like a brick would be. Like concrete would be. It has a certain amount of plasticity, has a certain amount of movement. So lime is a favourite substance for building, for brickwork, by certain people. And actually in today's society, people are going against ordinary cement and they're going towards lime. And then, of course, sheep's wool is a natural substance. People are using sheep's wool for insulation in buildings. And, of course, the great thing about sheep's wool is that the sheep will always keep growing the wool. So it is a sustainable source. We also need to talk about energy efficiency. It's not just enough to heat your building with enough heat. It's also about making sure that you don't lose that heat. And of course, the big thing that will prevent heat from being lost in a building is insulation. I'm just going to give you some facts and figures here. 12% of the heat of a building can be lost through just drafts. Okay, drafty doors, drafty windows, that can actually lose 12%. That's a lot. That's a lot of the heat just leaving a building. Another 3% can be lost simply by the type of front door you have. If you have a type of front door that is not particularly well insulated, a tremendous amount of heat can leave just that way. Not as much as other things, but it's 3%. Now through the floor can lose 8% of all the heat. We all know what it's like to stand on a cold floor. Well, not only does that floor feel cold to us, but the floor feels the warmth of the building. And so that warmth is being lost into the floor of about 8%. Now those numbers aren't particularly great numbers, but when you start then thinking about windows can lose up to 18%. 18%, that's nearly 20% of all the heat of a building. Through the walls, okay, The heat of the building can be up to 33% of the heat lost through walls. Now that's a very big deal. And also the roof, about 26% of heat can be lost through the roof. So we can understand then, when we look at those numbers, we can understand the importance of insulating a house. It's not enough just to say, well, I'm warm now. No, the heat's going to go and you'll need more heat and more heat and more heat. And so there are a number of things that can be used to insulate. We're going to talk about 4 of them just now. One is called blue jean or lamb's wool. It's lamb's wool. It's a natural insulator. That's what the sheep need to keep warm in the winter. But when the summer comes or the spring comes and it gets very hot, they have all this wool taken away and they're very relieved to have it taken away. Blue jean insulation comes from recycling denim. Now, I don't know whether you knew that, but when wool is made of cotton, denim is made of cotton, and when it's all cut up and mushed, it turns into a blue denim blanket. It can also be supplied in like a sort of a powdered form, but it mainly is supplied in the form of a blanket. Then, of course, the next one is fiberglass mineral wool. Now, fiberglass mineral wool is literally what it says it is. It's glass, but it's been blown into a fibre. It's very fine fibres. They're so fine, in fact, that actually, if you're not careful, they stick into you and they feel like a needle sticking into you. What the great thing about glass fibre is that it is easy to produce and easy to work with. Okay, and it's made out of old recycled bottles and minerals and mineral wool. And the whole idea is it's like a very thick blanket. But it's recommended at the moment, I understand, that you should have at least 4 inches of blanket in the roof. And sometimes they put it into the walls as well as the building is being built. And then we have let's see if I can say this right, polyisocyanurate. Okay, I'll try and say that best I can. We call it PIR, polyisocyanurate. Now this is solid sheet or a solid block of insulation. You may say, how good is it? Well, it's equivalent to about 30 inches of fiberglass mineral wool. It is exceptionally high insulation, and that can be put either into brickwork, or it can be put into roofs, or it can be put into floors. But the main thing is its insulation value is so very, very high. And there's another one as well, a modern type of insulation made up of lots of layers of foil and thin insulation layers. It's called multifoil. So this looks like a book made out of thin aluminium, and every single sheet, okay, traps a tiny bit of air in between it. So as you pack this multifoil in, so air stops moving. When air stops moving, then that insulates. And that's the whole idea behind insulation, to make a layer whereby the air inside isn't circulating, it's stationary. That stationary air is what insulation is all about. And there's another type of insulation, which while I'm talking about it, it's not like any of those. It's the insulation that we have in windows. We sometimes call it double glazing. We sometimes call it draft proofing measures. Okay, there's all sorts of draft proofing measures, but the important thing about insulation is, the important thing about double glazing is that you have 2 special layers of glass, and what's in between them is not air. What's in between them is a special air that's inert. It does not allow the air to circulate, and it does not easily allow heat to transfer between the 2 panes. If you make the panes too far apart, then the air starts to circulate and then you lose its insulation effect. If you make them too close together, then the bridge is too close and the heat transfers quickly between the 2. So it is a question of getting exactly the right distance. And sometimes people use triple glazing, you see, and other people use types of glass that reflect heat, amazingly. So in the summertime they stop the house getting too hot, and in the wintertime they stop the building getting too cold. Clever, isn't it? Amazing what people do nowadays. And of course, there's making better use of existing and free energy. Now, when you go out on a hot day in the summertime, you feel the heat immediately on your skin. That heat from the sun can be harnessed. That heat can come down onto special photoelectric cells. And what those photoelectric cells do is they produce a small electric current. It may be only 1/3 of a volt, but accumulatively it can be multiplied and multiplied and multiplied, and that heat can go into either making electricity and putting the electricity into batteries. So they charge the batteries in the day when the sun is shining, and then at night time when you need the electricity, you switch from the battery straight into the lighting of your home or the heating of your home. There's other ways of doing it as well. I mean, it's possible to have the sort of panels whereby where water is passed through the panels, and they're specially designed so that as the water goes through them, so they're warmed up. The sun warms up the water, and this comes through the house, and as it goes through the house, it goes through a cylinder which transfers the heat into the water of the house. So the water of the house then becomes hot from the water that's on the solar panel on the outside of the house. This is all very clever technology. There's other forms of heating as well. There's things like passive heating. It used to be that years ago people would put a small concrete wall just on the inside of their window, and it'd be painted black, and all day long the sun would shine on it, and then in the evening the heat would then come back out of that wall, and it would bring heating to the house. So people have been doing these things for a very, very long time, for hundreds of years, and it's very, very clever, some of it. Another one is called heat source and recovery. So humans, right, we give off a fair bit of energy as they go through their normal day. We get body heat, we had heat given off by hair dryers or by cookers or by refrigerators and all sorts of other activities, and this can then be conserved. And modern air conditioning systems, they take the heat from the use of the building, and then they recycle it, and they bring fresh air into the building. So not only can they cool the air, but they can warm the air at the same time. So this is very clever technology. In the wintertime, they take heat from outside when the sun is shining and bring it into the building. This is exceptionally, that normally there's a brain inside these machines that tell it exactly what to do. We also have some other renewable sources of power. One is wind power. Now, funnily enough, wind power isn't getting such a good rap at the moment because they're finding that the cost of installation is very high compared with what people get out of it. And it produces in the country something like about, is it 1 or 2%, something like that, of the amount of electricity that can be supplied. And that, of course, can be very frustrating because it goes for a number of days sometimes without any wind. And then the other thing that's very strange about it is that sometimes the wind turbines can be blown over. So this is another problem. So there's all of the different ways that are used for sustainable energy, all have their upside and their downside. One of the most sustainable forms of electrical generation is water power. So these are exceptionally good, and it needs a big dam, it needs a big lake, but they do have the ability to be able to turn vast generators, and those vast generators do produce a lot of power. There's a few clever systems. There's one up in Wales whereby water's taken from a lake down below and is pumped up into the mountain all day long, and then at night time when everybody comes home and turns all the power on and turns the toaster on and turns the kettle on, they pump water from the top reservoir straight back down into the bottom one, and that turns the generator, and the power is instant. So that's how we're able to have electricity when it's needed. Wow, there's a lot here, isn't it? Now, there's a few other things we need to talk about. One is called biomass heating. So this is heating a house using wood or other non-fossil fuels, it also becomes very popular that these systems can heat water efficiently as well as heating rooms. And of course, well-established, a well-insulated building does not require a lot of heating. So people can use wood chip, they can use various forms of biomass. Biomass just means a mass of material that's made out of something that's biological, something that grows. And the most common thing is wood. I have a friend of mine who lives down in South Shropshire, and they have a small mini forest, just a little forest. It's only like about an acre, and every season they grow willow. So the willow comes up, and at the end of the season it's all cut down, and guess what happens? It immediately starts to grow again. And so they're able to heat their house all the way through the year just by the use of their own little private forest. Quite clever, isn't it? Energy efficient goods and appliances are exceptionally important in this race to keep warm, because low energy bulbs and low energy machines, like for example a washing machine or a fridge, they actually are very, very important. There's laws now passed to make sure that we actually don't waste electricity, because it's such a precious commodity. And we need to, of course, protect the environment. We don't want to be wasting fuel, and we don't want to be wasting energy. And so that is very important, and we need to make all efforts we can do to conserve our money and to conserve our buildings and to keep them warm and safe. Well, that's the end of this particular section, so we look forward to catching up with you next time. Have a great day. Bye for now.